Okay, the majority of this video is talking about quadratic equations, factoring, and the quadratic formula. So the first type of quadratic equation we can have, the first form, is vertex form, which is y equals a parentheses x minus h squared plus k. We should recognize vertex form. And then also standard form. Standard form is y equals ax squared plus bx plus c. If we are given either of these forms, we should be able to name what the form is. If the question is asking you to change an equation from standard form to vertex form, we have to know what those forms look like in order to do that. Okay, so we are going to start by factoring. We want to factor 3x squared plus 10x plus 8. We need to use factoring by grouping. Normally we try to factor out the number that's in front of x squared, but since our other two terms are 10 and 8, we can't take a 3 out of these two. So factoring by grouping is going to be our option here. We multiply the 3 times the 8. 3 times 8 gives us 24. And then we're listing the factors of 24, and we're trying to find the 2 that will add to give us the middle term. We're looking for the factors of 24 that will add to give us 10. And so we have 1 and 24, 3 and 8, 2 and 12, 4 and 6, and I think we just found them. So we split the 10x up into 6x plus 4x, or vice versa, same thing. And we group our first two terms and our second two terms. And we're going to factor out the greatest common factor. In this case, 3x squared and 6x, the greatest common factor is 3x. And we write whatever's left over inside the parentheses. So 3x squared divided by 3x leaves us with x. 6x divided by 3x leaves us with 2. For the second one, our greatest common factor for 4x and 8 is going to be 4. 4x divided by 4 leaves us with x. And 8 divided by 4 gives us a positive 2. And this is where we can check ourselves. We have x plus 2 and x plus 2. You should have the same exact thing in both parentheses. If you don't, you're going to have to tweak what you did until you get the same exact thing. Go back and check your work, see if there's something that you need to change. So finally, we're ready to write our two binomials. The first binomial will be the x plus 2. We're going to factor this out of our two terms here. So I'm taking the x plus 2 out. And then what goes in the second binomial is whatever you have left. So just, if you can't really visualize it, cover up the x plus 2. If we cover up the x plus 2, what do we have left? We have 3x plus 4. That's what goes in our second binomial. And that is how we factor using grouping. Okay, for our next problems, we are factoring again, so we're not solving, just factoring. And this is something that we should notice. Whenever we have something that looks like this, we have the difference of two squares. 4x squared, this is a perfect square. 25 is also a perfect square, and we are subtracting. The difference of squares, that's where we have that formula. We have a shortcut here. We do two binomials, 1 plus, 1 minus. We find the square root of the first term. That goes in both binomials as the first term in both of our binomials. We do the square root of the second term, and that's going to be the second term in both binomials. So the square root of 4x squared is 2x. The square root of 25 is 5. So when we factor this, it will be 2x plus 5, 2x minus 5. For the second problem, we have 36x squared minus 49. So again, this is a perfect square. 49, also a perfect square. And we are subtracting. So this is the difference of two squares. So we set up two binomials, 1 plus, 1 minus. We take the square root of 36x squared. It's going to be 6x. So that is going to be our first term in both binomials. Next, we take the square root of our second term. The square root of 49 is 7. So that will be our second term in both binomials. And that's it. That's all we have to do. Okay, for the next problem, we are actually finding the solutions. So here we are going to be solving. not just factoring, we're actually going to solve. So we can do this in multiple ways. You can use factoring by grouping. You can use completing the square. You can use quadratic formula. And for this one, we are going to use the quadratic formula because we do have to know how to do that for the test. Okay, so our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And we're plugging in a, b, and c. So a in this case is 3, b is -7, and c is -2. So when I plug these in, I end up with x is equal to the opposite of -7 plus or minus the square root of -7 squared minus 4 times a, which is 3, times c, which is -2. All over 2 times a, so 2 times 3. And then from here, I am just simplifying. So this is equal to positive 7 plus or minus the square root. 7 squared, -7 squared, sorry, gives us 49. And we multiply what's here. -4 times 3 times -2 is going to give us a positive 24. All over 2 times 3, which is 6. So then continuing to simplify, I'm going to add what's under my square roots. So 7 plus or minus the square root of 49 plus 24, which is 73. All over 6. If we wanted to, we could take this and separate it into 7 plus the square root of 73 over 6 and 7 minus the square root of 73 over 6. This is going to give us our two answers, but since the square root of 73 is not a perfect square, if we want exact answers, we would have to leave it with the square root. So this is going to be our answer here. If we were able to estimate, if the context of the question was asking for something where we could have a decimal, where we can round, then we would go ahead and take this and plug it into our calculators and figure out what this is approximately. Okay, but our answer, if we want exact answers, is going to be 7 plus or minus square root of 73 over 6. Okay, for the next one, this one is solving using roots. So if we ever have something that looks like this, we have an x squared. There is no x term, but we do have a constant. This is not the difference of two squares. So what we can do is solve using roots, just solve for x. So I'm going to start by moving the 27 to the right. I move it over to the right side of the equal sign. It's a minus 27, so I am going to add 27 to both sides. So I end up with 3x squared is equal to 27. And I continue solving it as if I were solving a linear equation. I divide by 3. So I end up with x squared equals 9. And then, to get x by itself, I need to get rid of the squared symbol. So opposite of squaring something is to take the square root of it. So I take the square root of both sides, and I end up with x is equal to, the square root of 9 is plus or minus 3. And we can write that in two ways. We can write it as x equals plus or minus 3, or we can say x is equal to 3, comma, negative 3. Okay, next we are going to find the discriminant. So the discriminant has a formula, and you have to remember what the formula is. B squared minus 4ac. It is what's under the square root in the quadratic formula. So b squared minus 4ac. Okay, so we are going to use the example 2x squared plus 3x minus 2. To find the discriminant, I have to label a, b, and c. So a is the number in front of x squared, b is the number in front of x, and c is our constant. Okay, so a is 2, b is 3, and c is negative 2. And I'm just plugging these into the formula. So b squared minus 4ac. My b is 3, so I'm plugging 3 in here. 3 squared minus 4 times a, which is 2, times c, which is negative 2. And then I simplify. So 3 squared, this is 3 times 3, which is 9. And then I'm doing -4 times 2 times -2. That's going to give me a positive 16. And then I just add 9 plus 16 gives me 25. So my discriminant in this case is 25, and that would be my answer.